Welcome to AI Frontiers, where we explore the cutting-edge research reshaping our world. Today we're diving into the emotional intelligence revolution in artificial intelligence, examining 16 groundbreaking papers from Computational Linguistics published on August 20th, 2025. We're witnessing a transformation from simple pattern matching to genuine language comprehension, as researchers build AI systems that understand the nuances of human communication and bridge the gap between human expression and machine intelligence. Picture this. You're reading a beautiful poem by Emily Dickinson, and you wonder whether a computer could understand the subtle melancholy woven through her words. Could artificial intelligence detect the difference between the bitter irony in Oscar Wilde's wit and the gentle sorrow in a Shakespearean sonnet? This reveals a surprising challenge that exposes AI's current limitations. Traditional AI struggles with emotional nuance in literature. There's a vast difference between a parrot repeating words and a poet understanding meaning. Until recently, computers couldn't detect the emotional landscapes in text, but today's research is changing this fundamental limitation. These 16 papers from August 20th, 2025 aren't just academic exercises. They're the building blocks of tomorrow's AI systems. By the end of our journey together, you'll understand how researchers are teaching machines to feel the pulse of human emotion in text, break down language barriers with unprecedented sophistication, and tackle some of the most complex challenges in artificial intelligence. We're witnessing the transformation from impressive demonstrations to practical AI solutions that will fundamentally change how machines understand human communication. Think of computational linguistics as the ultimate translator, not just between languages, but between the messy, beautiful complexity of human communication and the precise, logical world of computers. This field sits at the crossroads where computer science meets linguistics, psychology, and philosophy. It's like building a bridge between two completely different worlds, one where meaning flows in metaphors, cultural references, and emotional undertones, and another where everything must be reduced to mathematical patterns and statistical probabilities. These systems power the voice assistants in our homes, enable real-time translation services, and help create conversational AI. Computational linguistics serves as the critical bridge toward artificial general intelligence. Our first major research theme focuses on data quality revolution, where quality trumps quantity in AI trading. The Nemotron-CC-Math research demonstrates the power of curated data through a novel pipeline that extracts high-quality mathematical content from web chaos. This approach achieved remarkable improvements of 4.8 to 12.6 points on mathematical reasoning benchmarks. It's like finding diamonds in a coal mine. This breakthrough proves that targeted approaches can outperform brute force scaling, suggesting that domain-specific data curation may be more impactful than simply building bigger models. The implications extend far beyond mathematics, potentially transforming how we trade AI systems for any specialized field. The second theme focuses on multilingual mastery, teaching AI to think in many languages, rather than simply translating between them. Research reveals that chain-of-thought reasoning varies dramatically across languages. While using English as a bridge, language provides no benefit for French speakers. It actually improves performance for Japanese and Latvian, and proves insufficient for Swahili. Code switching affects AI performance in complex ways that researchers are only beginning to understand. This work involves developing specialized datasets for multilingual conversational AI, reflecting a growing recognition that truly useful AI systems must serve our wonderfully diverse global linguistic community. The findings shatter assumptions about universal language transfer. Theme 3 revolves around domain specialization, moving from generalist to expert AI systems. Researchers are creating AI tailored for specific fields like traditional Chinese medicine, urban transportation systems, and clinical reasoning over electronic health records. It's like the difference between a general practitioner and a specialist surgeon. This includes sophisticated analysis of electronic health records with domain-specific expertise. The field is moving from impressive demonstrations to real-world applications with specialized requirements. This specialization trend indicates that computational linguistics is maturing, developing solutions that can handle the unique challenges of different professional domains rather than relying on one-size-fits-all approaches. One of the most significant breakthroughs comes from mathematical reasoning research, representing a David versus Goliath story in the AI world. The Nemotron-CC-Math work achieved 4.8 to 12.6-point improvements on mathematical reasoning benchmarks through smart data curation rather than building bigger models. This domain-specific curation approach proved more impactful than model scaling, potentially transforming AI training for medicine, law, engineering, and other specialized fields. The findings shatter assumptions about universal language transfer, suggesting that the future of AI development may lie in carefully crafted domain-specific approaches rather than simply scaling up general-purpose models. For our paper of the day, we're exploring continuous sentiment analysis for literature by Lyngbaek and colleagues. This research tackles the nuanced emotional landscapes in literary texts, addressing how traditional sentiment analysis tools fail when confronted with sophisticated literary works. Most existing systems work well for straightforward expressions, but stumble when faced with Hemingway's subtle melancholy or Jane Austen's biting irony. It's like trying to explain a symphony using only the words loud and quiet. The researchers developed continuous scoring instead of rigid emotional categories, creating a breakthrough in multilingual emotional understanding that works across different languages and cultural contexts. The technical innovation centers on concept vector projection, creating emotional spectrums instead of emotional buckets. The approach works by creating dense vector representations of words and concepts that capture their semantic relationships, then projecting these vectors onto sentiment dimensions to produce continuous numerical scores. Think of this as creating a multi-dimensional emotional map, where related feelings cluster together, and the system can navigate this map to find precise emotional coordinates of any text passage. Instead of simply categorizing text as sad, the system can detect gradations like wistfully melancholic, deeply tragic, or tinged with nostalgic sorrow. This method works effectively across English and Danish literary traditions. The results were revolutionary, with AI sentiment scores aligning with human literary interpretation. The continuous sentiment scoring method significantly outperformed dictionary-based tools on both English and Danish literary texts. Most importantly, the sentiment score distributions produced by the computational model closely matched those created by human annotators, suggesting the system successfully captured the same emotional dimensions that humans perceive when reading literature. The approach worked across different languages and historical periods, opening new possibilities for comparative literary studies and creating a bridge between quantitative analysis and literary criticism that scholars had long sought. Looking toward future horizons, computational linguistics faces the challenge of building a creative communication network. Currently, it's like building a global network where most connections run through a few major hubs. Future research must develop methods for underrepresented languages worldwide, addressing the vast majority of languages that remain underrepresented in computational linguistics research. We need interpretable AI systems for critical applications in healthcare, legal systems, and education. Multimodal integration represents another frontier, combining language with gestures, facial expressions, tone, and context. Perhaps most exciting is the potential for truly creative language use, beyond pattern recombination, and personalized AI that adapts to individual communication styles. In conclusion, we're witnessing the evolution from pattern matching to genuine understanding in the conversation between humans and machines. Quality data curation yields dramatic AI improvements, while multilingual approaches require culture-specific strategies rather than universal solutions. The specialization trend reflects field maturity and real-world needs, moving beyond impressive demonstrations to practical applications. Continuous sentiment analysis represents broader trends toward nuanced analysis capabilities that capture the full richness of human language use. Most importantly, this research is expanding our understanding of language itself, providing new insights into fundamental questions about human cognition and communication through computational methods. This presentation demonstrates our AI synthesis and review process for transparency. The content was synthesized using advanced language models including GPT and Anthropic Claude Sonnet with text-to-speech synthesis powered by Deepgram technology. Image generation capabilities were provided through OpenAI systems. Human expert review of the synthesized content was conducted to ensure accuracy and clarity. We acknowledge that some oversights may exist despite our review process, and we provide references to original research papers for verification. This multi-stage approach ensures we deliver accurate, accessible content while maintaining scientific rigor. Thank you for joining AI Frontiers as we explore the cutting-edge research reshaping our world. Subscribe to our channel for daily insights into the intersection of technology and human communication. Engage with the research community, share your thoughts on social media, and be part of the future of human-computer communication. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.